Hi guys, welcome our world. We are the Weirdos United 22. First of all, thank you for watching our video. Let me tell you what is physics. Physics is a natural science whose goal is to understand how everything works at its most fundamental level. And today, we want to talk about circular motion or physics. In this video, we will focus on four main points. This is our debate contest, and today we will tell you these points. So, you guys are ready to see our video? Okay, let's get started.
Hello everyone, I'm going to introduce what is circular motion. If you ask what is circular motion is described as the movement along circular path. Circular motion is specific type of two-dimensional motion. I think you all know what is two-dimensional motion because it is already explained in pro-two motion, but I will explain again. Two-dimensional motion is a motion that moves in both x and y directions simultaneously. In circular motion, speed is constant, but you should note that its velocity is not constant because direction in circular motion keeps changing. Direction of the velocity in circular motion is tangential to the path. If the ball is tied to the end of a string and rotated horizontally over the head, the ball is moving with circular motion.
Hi guys, today I talk about angular displacement. But what is angular displacement? Do you know that? Whatever, I explain today. Angular displacement, also called angular rotation of a physical body, is the angle toward the body rotate around a center or axis of rotation. Change the angular position. It's called the angular displacement theta. Why angular position? Angular position is defined by measuring how far the body is rotated from the reference line, as shown in the figure. Do you know if the object is on the reference line, its angular position is 0? The angular displacement is the ratio of the outline to radius. Unit for angular displacement, radian. The magnitude of angular displacement theta measured radian. Angular displacement can also be expressed in degree of revolution. 2 pi radian equals 360 degrees. The angular displacement is not a line nor measured in meter, so an angular displacement is different than a linear displacement.
Start from now, I'm gonna explain what the angular velocity is. Before we move to angular velocity, we should know what the tangential velocity is. So I will explain it. However, the object is spinning around the circles. The speed is constant, but the direction is continuously changing. So the velocity in circular motion called tangential velocity is not constant, it's changing. Tangential velocity is the linear speed of any object moving along the circular path. As you can see in the picture, there are 2 points. They are showing the direction of the tangential velocity. I believe that you can see the picture of circles in the screen. On the screen, there are 2 points A and B on the circles. Point A is colored with red and point B is colored with blue. Point A has a shorter distance to travel, but point B has to travel longer distance. In order to spin at the same rate, point B has to travel faster than point A. So, tangential velocity of point B is greater than point A. Note that tangential velocity decreases from the center to the poles. There is known as the angular velocity terms. The angular velocity tells you how fast the object is spinning on the circles with the same angular velocity. The change of angular displacement is where the average angular velocity begins. Whenever the points are on the circles, as you can see in the picture, there are 2 points. I refer to that. They all have the same angular velocity because each of those points is rotated through the same angles and in the same period of time. The symbol of angular velocity is omega. Formula for angular velocity is omega equal to delta theta by delta g. At constant angular velocity, note that average omega is equal to omega.
Hi guys, I'm going to tell you about every instantaneous angular acceleration. Guys, you know, every angular acceleration refers to the rate of change of angular velocity over given time. Remember this, over given time. Its form is defining the change in the angular velocity by the change in time. Its equation is F equals omega 2 minus omega 1 by T2 minus T1. Showing the left right corner are about the symbol. Oh, what is shown in this picture is about every angular acceleration that I just talked about. In this picture, you can see final position and internal position, FR, and directional motion. Oh, this is now about close corner Y and corner Y. Let's all look at this picture shown about right corner. In this picture, omega and FR both have the same sign, plus and plus. So this object will be increased speed. It's called close corner Y. Why they have different sign, plus and minus, the object will slow down. It's called close Y. When the body is moving with a constant angular acceleration, Fr bar and Fr are the same. Like Fr bar equal omega by t. In instantaneous angular acceleration, the instantaneous is defined as the time of the every angular acceleration as the time goes to zero. Guys, remember this. Time go to zero. The time interval delta t approach zero is equation will be Fr equal d omega by dt. Showing the right left corner is about every and instantaneous angular acceleration equation. Guys, remember this. Both every and instantaneous angular acceleration are measured in radian per second square. Radian per second square.
Hi, I'm Bill and I'm B, and I'm going to talk about relations between angular and linear quantities before I continue with motions of angular and linear. Angular motions and linear motions is about straight line movement, and the connections between them depends on the radius circular path. So what about durations? Displacement of angular and linear are connected by s equal to r theta, and velocity of angular and linear are connected by v equal to r omega, and also accelerations of angular and linear are connected by a equal to r alpha. So you can see this image. So this image shows two types of basic equations, linear and angular. Linear equations involve straight lines, while angular equations involve multiple angles. So anyways, angular velocity and angular accelerations of the quantities is very important, and the ratios of linear accelerations is tangential to the path and called the tangential accelerations. And the unit of omega is radius per second and Fr is radius per second squared. Understanding this relationship is the key in physics and engineering when dealing with rational or circular motion. These images are examples of circular paths, and the first one is Earth rotations around the sun, and second one is spinning the wheel.
Hi guys, my dear Weirdos from the Cuddy here. So, the try is this. You need a ball attached to a string, but right now we don't have a ball, so I'm just gonna use a tape instead of a ball. I hope that's okay. Let's start.
Okay, we need to make it quick. I don't want my video more than 2 minutes, so let's start. When an object goes around in a cycle, the description of motion becomes interesting in many ways. You have to move constantly in a circular motion, then we observe two things. First, the speed of the tape is constant. At every point in motion, the tape changes direction. Therefore, we can say that in order to stay on a circular path, the tape has to change direction continuously. As you just saw, the longer the string, the faster it goes. So let's shorten the length of the string. From the second one, the second law of motion tells that there can be no acceleration without enough force, so there must be a force associated with the circular motion. Thus, the change in direction is a result of a centripetal force. Centripetal force is the force acting on a body in a circular path.
I have to do it again.
The moment the string breaks or you let go of the string, the centripetal force starts acting and the tape fly away, just like how to do it.
This is our members, and we trying the best together. I would like to thank you for your attention today. I hope you all have a wonderful day. Bye bye.